Satellite information underpins a lot of our everyday activities, making a phone call, finding directions, withdrawing money from an ATM. But data collected by satellites has wider societal benefits. Hi, my name's Martina Doblin. I'm a researcher at the University of Technology, Sydney, and I look at satellite imagery to study changes of productivity in the ocean. Satellites help track freshwater resources and help monitor the health of our agricultural systems for food security. Satellite information is used in the health sector, monitoring air and water quality for infectious diseases, and is also used to help map renewable energy potential. The first satellites for Earth observation were launched over 40 years ago in 1960, about 9 years before humans first set foot on the moon. Since then, there's been massive growth of satellite activity worldwide. These early Earth-observing satellites were capable of measuring much of what we continue to investigate today, such as the ocean, land, clouds, trace gases and radiation. Satellites look a little like space toys or mechanical flies, with a central body housing the control system and instruments, and one or more wing-like projections that are used to capture solar energy and power the satellite. A major component of a satellite is the antenna and a high-frequency radio receiver. These are used to position the satellite correctly and transmit the signal back down to Earth. The measurements themselves are in the form of electrical voltages, which are digitised and then transmitted to receiving stations on the ground. The data is then relayed to various centres around the world and are made available over the internet in the form of images or gridded datasets. With over 18,000 objects measuring 10 centimetres across or more orbiting around the Earth, there is a need to monitor priority spacecraft, including military satellites and the Space Shuttle, to calculate risk of collision. The most comprehensive catalogue of space objects is maintained by the Pentagon, which uses optical telescopes and radar to track them. Relevant to marine science, satellites collect data on the status and trends of the world's oceans and enable decision-making in support of the conservation of natural resources. Ocean colour sensors began in 1978 and help us learn about climate and climate change. Satellite data applications have allowed us to understand sea level variation, freshwater availability, weather patterns and other geophysical processes affecting the marine environment. Given its central importance in Earth observation, satellite data is a critical component of IMOS, which is Australia's integrated marine observing system, whose function is to manage and share satellite and other data so that it can be analysed and used in teaching and research applications. Australia has a marine estate larger than its land surface, so there is a vast amount of ocean to govern, and satellites are the most cost-effective method of keeping track of the condition of our precious coastal resources.